The second half, this is chapter 9F right here. So we're just going to be finding the x and the y intercepts, okay? So the x-intercept, you just make sure y is equal to 0, okay? So the x-intercept is the point on the graph where the line crosses the x-axis, okay? When it says V line meaning your rule, okay? Substitute y equals 0, solve for x, write as coordinate, okay? That's all it is. So let's just apply that to an actual question. So I have here y equals to x plus 4. So I want to find the y-intercept. I'm going to let y equals to 0. What I mean by that is just replace the letter y with the number 0 instead. So 0 equals to 2x plus 4. And now we just solve for x. Minus 4, 0 minus 4. So I get negative 4 equals to 2x. And then finally, you divide both sides by 2 because remember, we're solving for x, so get rid of everything. Negative 4 divided by 2 is negative 2, and then you just end up with that, okay? But I like to write it the other way around. So x equals negative 2. And then finally, I'm going to write this as a coordinate point, negative 2, 0, because if you remember from the previous slide, write as coordinate x, 0, just like that. And that's what I've done. Because I found x is negative 2, just replace it. Now the y-intercept. The y-intercept is the point on the graph where the line crosses the y-axis, and just remember the line meaning your rule. So just remember x equals 0. Substitute it, solve for y, write as coordinate 0y. Let's do that. So I have my y-intercept, x equals to 0, y equals to 2 bracket 0 plus 4, because I'm replacing the letter x with the number 0 now. 2 times 0 is 0 plus 4, and then 0 plus 4 is just 4. That means as a coordinate, this will be 0, 4. This based off the previous slide right there. Okay. Now, just a note, your constant in the rule is actually the y-intercept value. So if you have a look up here, previously we found that the y-intercept is at 0, 4. But if you like make the comparison, if you have a look at that, that's your constant right there. It's the same number, okay? Same number as what you found it to be. So you can pretty much use the cheat code and just be like, hey, I recognize the constant is the y-intercept, so I'm just going to call it that, okay? But I recommend to practice substituting and then solving because this is a skill that, that's quite important for next year onwards, okay? So that's what this note means. And then obviously when you draw your graph, you can sort of see it, but I'm not going to bother showing that to you. Um, Now, how to how to graph after finding intercepts. What you're going to do is you're going to plot your coordinate points. So based off what you found here, your x and your y intercept. So you're going to plot your x intercept and you're also going to plot your y intercept on your graph. Once you plot those 2 points, you just connect the 2 points with a line. So make sure you have your ruler. Okay, that's all it is. All right, chapter 9G is the gradient. The gradient just means it measures how steep a line is. Okay, it's a number and it's the increase or decrease in y as x increases by 1. Now, I talked about this earlier in part 1 of the video. So basically, if you remember from your table of values, chapter 9C, you can refer to it back there. Okay. Now, there's different types of gradients, and you need to know the distinct differences. So you got positive. So just have a look at my line that I'm drawing here. I'm looking at it from left to right. So basically, where my line begins on the left hand side, and then I move across, I can see that my red line is increasing. It's going up. Okay. When it's going up, the y value increases. Okay. For negative, you look from left to right, my y value is decreasing. So as you can see, if I start from the left hand side and I move all the way across to the right, I can see that my red line is going down. Okay. The y value is decreasing. Now, the rise is negative. This here is important for a bit later. Um, and then you got to think about this like going down the staircase. Okay, now you don't need to write that down, but that's just the analogy there. A zero gradient. So it's just a horizontal line. Okay. So say for example, if you are given a graph like this horizontal line here, it has a gradient of zero. Okay, this is a zero gradient type of line. And the reason why is because if you do 0 divided by any number, it will just equal to 0 if you type it in your calculator, okay? The final one is an undefined line. This is a vertical line. You can't measure it, no number exists. Now, if you were to type this in your calculator, any number divided by 0, it just says error, okay? So you can't really like call it something. So that's why we just say it's undefined instead. Because if you remember, if you um, divide any number by 0, just doesn't work. And you can type in any number you want in your calculator just to double check. So in my example here, label what type of gradients are line A, B, C, and D. I've already done it for you, okay? So if you just look at the green line, I can see it's a negative, and then the rest is all there, okay? Now, how would we find the gradient? What you need are two coordinate points. This is very important, okay? What you're going to do next is you're going to make a triangle. I didn't explain this to you earlier, but that's pretty much the whole concept here. You're pretty much making triangles and then you're going to calculate like your base and your height. Or in this case, we're going to call it the rise and the run, okay? This is a formula that you use. M is equal to rise over run. This is gradient. And the rise is the change in the y values. The run is the change in the x values. So let's just do it properly here. So let's just erase all this. Start fresh. So I've got my line. I'm going to make a triangle, okay, using those two coordinate points. So because the coordinate points are already there, I can just make a triangle using that. I'm going to find what the rise is and the run. So the rise being the change in the y value. So how far apart are the y values? Or you could just be like, hey, what's the height of this triangle? Or you could say height of triangle. And you could say this is the base of triangle. So how tall is this triangle here? I can see it's 4. And then for the run, it's a change in the x values, or you're trying to find the base of it. How long is the base? I can see that this is also 4 as well. Now, just something to note, this is a negative gradient. Now, because it's a negative gradient, if you have a look back on our negative gradient slide, the rise is negative. So that means our rise value, in this case, it's not just 4, it's actually going to be -4, okay? And when you try to find the gradient, it's gonna substitute the numbers in. So my rise is -4, my run is just 4. Negative 4 divided by 4 is negative 1. So m equals to negative 1. Okay. Now, for my second example here, I'm only given one coordinate right now. So I need to like find the second coordinate. So just looking at that line, there is one point that's standing out to me, and that is this point right here, the origin, the 0. And obviously, when you write that as a coordinate, it's 0, 0. Now, because I have my two coordinate points, I can now technically draw a triangle using those two coordinate points. I'm now going to find my rise. I'm now going to find my run, just like that. Now, this is a positive gradient. So just remember, if you're given a positive gradient, both your rise and your run are positive numbers. I should probably just write that down somewhere, just like rise is positive, your run is also positive. I'll just say here your rise is negative, and then your run is just positive. Your run is always positive, regardless, okay? Doesn't matter. So let's just find what the gradient is. So m equals to rise over run. I we need to find the rise first. So the height of the triangle, 1, 2, 3. Your run, okay, the base of the triangle is 1, 2. So this equals to 3 over 2. Now, just remember, if you're given like fractions in any way, simplify them as much as you can. But if you can't simplify it, just leave it as it is, okay? This is one of those scenarios where you just have to leave it as it is because you can't divide 3 by 2. You can't simplify that in any way. Next is the gradient intercept form. So just remember, this is the general equation or the rule. You can just say rule of a straight line. Now your m is your gradient, your c value, aka your constant, is the y-intercept, okay? You can say or constant. You can just say constant. Just call it y-intercept, okay? I prefer y-intercept. So just looking at the rule here, the question saying state the value of m and c for these graphs, okay? Or for these, I'll just say for these rules. So y equals 2x plus 3. So m is equal to 2, c is equal to 3, just like that. For part B, I have here m is equal to 1/3. It's whatever number is in front, okay? Whatever number is in front of the x there. Doesn't matter if it's a fraction. You just write the whole thing. And then you got c is equal to -4. Just remember your c value, take the sign with you as well, okay? Take the sign. Finding a rule from a graph. So let's just say they give you a graph and they ask you to find the rule because we don't know what it is. These are the steps you take. You calculate the gradient using rise over run. You spot the y-intercept from the graph, and then you just substitute your m and your c values that you find. So this is like finding c, and then you just replace them. So if you have a look at my example here, it's already been done, but I'll walk you through it. So I've got two coordinate points. All right, cool. Let's make a triangle. Let's make a triangle right here. You're going to first find the gradient. So you have your rise and then you have your run. You just sort of figure it out. We found it out to be the rise to be 2 and the run to be 1. And then you just figure it out. I'm left with m is equal to 2. Now you'll see it's just pretty much your y-intercept. So look at your graph and be like, hey, where's the y-intercept? Oh, it's at -1. Cool. So c equals to -1. And then what you're supposed to do technically is you're supposed to write this uh, y equals mx plus c. And then when you substitute it, it becomes 2x plus negative 1. Now, as you can see, I've got two sides connected to each other, so you just gotta combine them together. So you end up getting 2x minus 1. And that's what we got right there. Okay. Finally, applications. They're just worded problems. Okay. You just need to be careful and read the questions quite carefully. Okay. You can't use variables x and y only. There'll be scenarios where there'll be other letters that are more preferred. Read the question carefully. Okay. So just make sure that the variables that you select suit the question. What I'd recommend doing is highlighting or underlining what the question really wants you to do, because that will help you in the long run. So let's just do this full on example. It looks scary. Yeah, I get it. I understand. But just break it down into parts and we will get there. Okay. So the question is just simply saying a hiker walks at a constant rate of 4 kilometers per hour for 4 hours. Draw a table that should be of values using T for time in hours and D for distance in kilometers. Use T between 0 and 4. So I'm just going to go all through it now. So as you can see, I'm just going to highlight some keywords. So constant rate, 4 kilometers per hour. And then you have for 4 hours. So this is what we call the distance or no, this is not the distance. This is pretty much your gradient. This is pretty much your time. Okay. So when you use a table of values, just say, hey, when I first started at time 0, I haven't really walked anywhere. But after I walked for 1 hour, I've walked 4 kilometers. And then you sort of pretty much continue on with the pattern. Okay. So this is how you would construct your table of values right now. Now, part B here says draw a graph using part A. So basically, using the information from part A, draw a graph. So as you can see, I have drawn a graph right here. So just make sure that, your coordinates line up properly. And you see here, something to point out is you see my X and my Y axis, it's changed now. Because we've established new variables, you have to use the new variables, okay? So I've got my y-axis as the distance, and then my x-axis is the time. Part C says write a rule linking D with T. So just remember, just reading off the question, the rate of change is 4 kilometers per hour. Now, the initial distance that you covered is 0 kilometers. So you can pretty much write it like y equals mx plus c if you really wanted to. And then you can just like substitute, you can just use your skills using your table, be like, hey, the pattern is plus 4, plus 4, plus 4, plus 4. So I know my gradient is 4x plus c. And then if you really wanted to find what the c value using the table, okay, just remember it's the y value when x equals to 0. In this case, t equals 0. So you got to be careful there. So I know c is equal to 0. So now it's just y equals 4x. But because we're not using x and y, we now have to change this to d is equal to 4t, just like that. Part D, using your rule to find the distance. Use your rule to find the distance traveled for 2.5 hours of walking, okay? So this just literally means, hey, t is equal to 2.5. Find how long they've walked. So I've substituted t equals 2.5 in my rule, and I just found it. I found distance to be 10 kilometers. And finally, use your rule to find the time taken. Find the time taken to walk 8 kilometers. So that means your distance equals to 8. So substitute d equals 8, solve for t. As you can see, that's what I've done. And the time it took for this person to walk 8 hours, 8 kilometers is 2 hours. It's just like that. It's that simple. Okay. All right. Study hard. Good luck. Okay. If you have any questions, please tell me during the week so that I can help you out. Okay. Now, if we run out of time, come see me on. Wait, are we doing the test on Wednesday? No, we. Oh yeah. Just come see me. Um, during Monday or Tuesday, and then yeah, we'll go from there. Take care.